Hello and welcome in, everyone. I'm your host, Code Wonderland, and today we're playing some Comet 64. Now, last time that we played this, we got Disc 1 done, Disc 2 done, Disc A done, and most of Disc 3. We got Disc 3 done enough to get the code, and I got stumped on number 29 here, so we'll come back to that down the line when we go back to fully complete everything. But for now, we got the code, so let's keep moving. Let's go and do 31 coordinate pairs. Query. Input contains the x coordinate followed by the y coordinate of a point. Output the xy together. Input 2504, outputs 25 and 04. I mean, it should be pretty straightforward. So int equals input, reg equals input, and then output equals int reg, right? Oh, semicolons, as always. Reg is not a valid argument. Line 3. What do you mean it's not a valid argument? Let's look at reference for a second. Or is this under advanced concepts? I know I've seen that you can output coordinate pairs before in this documentation. I just haven't had to use it yet. Huh. It's somewhere in here. You know, I'm gonna laugh at this documentation is just somewhere randomly scattered throughout this game itself. I wonder if I don't need the parentheses. That's it. That's all it was. Alright. The ideals. Alright. Input contains two x coordinates followed by two y coordinates. Output the pair xy together. Example. Okay. So let's do int equals input, car equals int, int equals input, reg equals input, swap reg, reg equals input. Oh, but I'm doing it backwards. So maybe I want to instead so int equals input, so we grab the first x coordinate, first x, and then we want to keep that. So then we do reg equals input, second x. We don't care about the second x at the moment though, so we can swap reg. Alright, and then reg equals input, output equals int reg, int equals input, swap reg, and then is it just output equals reg int this time? I think that's right. I might have lost place of, oh, it's switch, not swap. Yeah, I think that's right. Yeah. Beautiful. 8 and 42, the ideal. Next question. Input contains an encrypted note. To decipher the secret message, replace every G with an E. Interesting. So string equals input. We're gonna need to reset int to I each time. Actually, no. String dot length. That's better. Loop car equals string int minus minus. Alright. And then check car equals G. Jump if, and let's just do a little, if false, loop check index is what we're going to call this actually, because we don't want to go to loop quite yet. So if the character is G, then string int equals E. Check index. Check int greater than 0. Jump if true, loop. Otherwise, we output string. Output equals string. This is not a return statement. On line 11, we're missing a semicolon. Wait. No, we're not. What's the problem with line 11? Expected car, line 11. Is this not a character? Can I not directly assign the character like that? No, it has to be the car variable. Got it. So car equals E, and then this equals car. I could do it in 4 less lines. Oh no, I did it in 4 less lines than the challenge, and I did it in a bunch less cycles. Got it. 203 less cycles to be exact. Oh, people have definitely done it better though. Oh my god. Oh no, I'm looking at this the wrong way. People still have done it better. Not necessarily in cycles though. It looks like we might line up with that. It's hard to really tell because of the way these angle, but I think that this lines up with the 790 here because I had 793. So this would be 13. Oh, so actually no, we are on 13, which is the highest. Okay, okay. This, I wish this was a little bit more like up and down, but I see why it's not. Alright. Root input. Input contains only perfect squares. Got it? Calculate the square root for each input and output the result. Interesting. How on earth do I get the square root? Do I have to loop through the possible squares? Okay, so int equals input, and then reg equals 0. No, I think that's fine for now. We'll leave that there. We'll probably need to put a loop here. So, and actually we need to make initialize reg to 1. Or we just do a reg plus plus here. Or do we swap int? Reg plus plus, no, int plus plus rather. No, because I want to be using reg here. Because I need to still compare to the end for the moment. So reg plus plus. No, actually no, I do want to switch int plus plus. So the reason I was thinking about the order here is like I only have 2 variables for ints. Technically 4 if you count car and switch. So I gotta be careful about like where and how I use it. So I'm like, for now, actually I have car. What am I doing? Oh, this is simple. Okay, so then we just back up car equals int equals 1, reg equals int times int, check int or reg equals car, jump if false, loop, and int plus plus, so we'll leave this at 0 to start. Output equals int. Ah, 49's out of the range of the alphabet, so I guess that doesn't quite work, huh? So we'll take this out here. Actually, we'll just switch int here. So switch int equals 0, int plus plus, reg equals int times int, switch int switch int there we go. So we just use the switch instead of the car there effectively. Solution has 2 more lines than expected, and we use 100 more steps. Alright. Is that clear on what I can do to fix that? What if I take out these and I switch here? I should still save us 1 line maybe? No. Is this still on the right playlist? Yeah, it is. Okay. Just making sure this isn't a DMCA free. I don't know how they got away with it, but we'll take it. Wait, why is it broken again? Oh. Switch int. Always leave your code in running state. Otherwise, when you go back to reference it, it will be trash. Alright. Query 0 marks at the end of a package. Or 0 marks at the end of a package. Output the first negative number in every package. If a package doesn't contain a negative number, output a 0 instead. Okay. So int equals input. Check int. Well, let's see. Let's check to see if reg is greater than -1. Jump if false. End. And then before that, check int equals 0. Jump if true, output answer. And then we'll have output answer and end. And so an output answer, oh wait. So if reg is greater than -1, so it's 0 or above, then we just keep going. Alright, wait, no. If false, so if reg is -1 or lower, then we skip to the end. Because at this point we've already established this is not a 0, this is just another number. We already have reg established, so we loop forward. Otherwise we go to output answer, which isn't quite right yet, because we still need to check int greater than 0. Jump if true, end. Beautiful. Then we go to assignment here. So then reg would equal int. So if input is 0, then we output answer. If input, or if reg is already set, we ignore this value. If the input is not negative, we ignore this value. Otherwise, we update reg for later. And then jump to end. Then move on to the next value. Man, I should really organize all of my code in this like this. So output answer is just output equals reg. And then at that point, we reset reg equals 0. Reset reg for next run. Look at that. We have 13 lines instead of 16, and we have more cycles. And those are the breaks. That's the trade-off. Hey, we got some binary. Alright. Input contains integers between 0 and 16. Output them after converting to binary. Alright. This should be pretty straightforward. It should basically be the same thing as what we did with the whatchamacallits, Roman numerals. That's what they're called. So let's grab that code as a starting point, because I think that will be helpful. Because, and this is something that, like, if you're not a programmer, if you haven't done a lot of programming, if you didn't go to school for programming, you might not know this, but like technically Roman numerals is the exact same thing as binary. It's the exact same thing as decimal system. It's the exact same thing as hexadecimal. It is a system of numbering, and that's it. It's just a different base. Although it's a little bit different because it's not an even base. It's more of like an odd case in that way. But we can still process it very similarly. So first, I'm assuming we're not going beyond a certain point. Yeah, we're going up to what, 16? Yeah, 16. So 16, check int. It would just be equal to 16 here because there's no other higher number here. So if we're equal to 16, we jump if false to the, what is that, the 8th place? 8, int minus equals 16. And actually, I mean, if it's 16, string equals 1111. And then jump to output answer. Yeah, right. Then let's see. So if it's 8, if int greater than 7, then, and if this is false, we go to the 4. And we'll effectively just copy and paste this and call it 4. Wait, am I looking at that right? It's 1, 2, 4, 8, 16. Yeah. Two. Okay. Yeah, that's right. And we don't need like an add I or anything, but we'll get to that in a second. So if the int is greater than 7, then we minus equals 8. And then if it's greater than 0, then wait a second, hold on. So minus equals 8. Let's just erase this for a second, because I feel like I'm looking at this other code and it's confusing me. So at this point we know that we can add to our string equals 0, 1. So otherwise, any other instance, we would just be appending besides 8 and 16, but there's nothing before 8 and 16, so signing it here isn't bad. We clear the string at the end there, yes, that's fine. So I mean, we could just do, I mean, there's no reason to do plus, it's fine. So if this is the case, then we do this. I mean, I think we're good from here because it should just fall through. And then let's see. Yeah, I think that's it. So if int is greater than 3, and then if not, we go to false. Then int equals int minus 4. String equals string plus 1. Wait a second. hold on. Jump if false. Add 0. We're gonna need an add after all. And then this is add 0. String plus 0. Okay, now this is making more sense. And then we have the return statement there, beautiful. Okay, so now we just do, if it's greater than 0, wait, no, we want it greater than 1. Wait, no, what am I talking about? Why is my brain breaking here? That's not how this works. So wait, hold on. There is still a ones place. Oh, I'm being dumb. I'm being dumb. 16 would be a fifth case, and it would be 10000. You know, if I would bother to read the questions a little bit better sometimes, it would help. I'm like, wait a second, something about this doesn't line up. Oh, no freaking wonder, bud. All right. So we don't even need to check that. So we're doing 15 here. And if it's not 15, then we add a 0 at the beginning. Then we get an 8. Then we get a 4. Right? Hold on. So if this is 1, it's 1. 1, 0 is 2. 1, 0, 0 should be 4. 1, 0, 0, 0 should be 8. 1, 1, 1, 1 should be 15, right? Because 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So 8, 4, 2, 1. So if it's 15, I don't even need to check this, actually. This is a waste of code, because I just need to check to see if the int is greater than 7. If it's greater than 7, then we add the 1. Because 8 would be 1000. Yeah. And then if it's greater than 3, so it contains a 4 beyond that point, then we add a 1 here. If it's greater than 1, then we add 1 here. And then we need to do 1s as well. String plus 1. And then check int equals 1, jump if false, add 0, jump if false, output answer. Change this to 1. I do actually need a label. And then otherwise we do string equals string plus 1, and then jump to output answer. We failed on some of them. Where did we fail? So we failed here. We outputted 1, 1. We outputted 3 when we needed a 2. We output, okay, so it's just where we're adding a 1 at the end. Oh, I need a -2 here. There we go. Beautiful. And just like that, we've hit 30 minutes for the day. We've gotten 36, also 6 of these done. So I think we'll call it there for today. If you liked the content, if you've been enjoying this, please subscribe to the channel. Every subscription helps. Like, comment, subscribe, do all the things. If you want to see me play other just kind of regular video games, check me out on Twitch at twitch.tv/CodeWonderland. And also, my husband and I have been working on an Apollo Justice playthrough. I've been leaving links to all the videos in a playlist on my profile, so feel free to check that out as well. We've really been working on improving the mic quality for dual mic setup for the more recent episodes, so definitely check those out. But until next time, bye!